Hi all. Okay, we're on the second lesson for this week. It's called combinations. Permutations and combinations kind of go together, just so you guys know. They're kind of, they're kind of learned together. So a combination is a collection of things in which the order does not matter. Remember, permutations, the order mattered. So like when we're, I just kind of want to talk about it for a second. So like if we're running for president, vice president, secretary, if we're picking a team captains, if we're picking first, second, third place, anything where order happens to matter, that's a permutation. A combination is like if we're just picking people for a team or for and it doesn't matter. I do want to say it kind of has to, you have to be careful on that one, because if you're deciding batting order for like softball or baseball, that does matter. It does matter what order you bat in. So if you're picking your lineup for like softball or baseball, that does matter. So you have to be careful there, whichever 9 players are. So depending on the sport, sometimes it matters, sometimes it doesn't. If you're just picking 5 players for basketball, doesn't matter which 5 you're picking. If you're picking the 8 or 9 players for baseball or softball, it matters. So you just have to kind of be careful and think about, does it really matter who it is and the batting order, or does it not? So I want to think about whether the order matters or not. So if it matters, it's a permutation. If it doesn't matter, it's a combination. So an example is, so for fruit salad, how many different combinations of 2 ingredients can I make with apple, banana, and cherry? Well, I can make 3. I can do an apple and a banana, apple and a cherry, or banana and cherry. And because it doesn't matter what order it is in, I can put anything first and anything second. So that's what the difference is. So now we're going to go on to a definition. Another definition, sorry. Combinations of n objects taken r at a time. So the number of combinations of r objects taken from a group of n distinct objects is denoted by NCR and is given by this formula. So we have NCR equals n factorial. In fact, it's going to look very similar to the permutation one, n minus r factorial. And then this is the different part, times r factorial. So the only thing different is we're adding this little r factorial onto the end. If it's a combination, makes it, I'm dividing by something else, so it makes it a little smaller. So I'm going to show you again, kind of like what I did last time. I'm going to use the example above, and I'm going to show you that it works. Notice that we have 3 here, right? 3 is what my answer should be. So I'm going to put it into this formula and show you that I get 3 as my answer. So I would say my combination, and I'm just going to switch colors so it's not the same combination, and I have 3 things, 3 types of fruit, and I want to choose 2 of them. So I have 3 factorial over 3 minus 2 factorial times 2 factorial. So that gives me 3 factorial over 1 factorial times 2 factorial, which is 3 times 2 factorial over 1 times 2 factorial. So there's a 1. So I'm going to get 3 over 1, or 3. So notice it's the same answer. That's just how it works. Same, very, very similar to permutation. Just going to work out the math there. So now we're going to show you some examples. And again, if you are going to use your calculator, guess what? If you found the permutation one, the combination one is just right there in the same area. You can tell the difference because permutation has a P, combination has a C, and in your calculator it's the same thing. The first one I'm going to go ahead and do out the math. The second one I'm going to put in my calculator and give you just the answers directly. So I have 9 items. I want to choose 6 of them, and I want to find the combination. So that's 9 factorial over 9 minus 6 factorial times 6 factorial. Okay, So that gives me 9 factorial over 3 factorial times 6 factorial. So I get 9 times 8 times 7 times 6 factorial over 3 times 2 times 1 times 6 factorial. So the 6's go away. 3 goes into 9 3 times. 2 goes into 8 4 times. So I'm going to get, I'm going to come over here because I'm running out of room. Well, it doesn't matter. I'm going to get 3 times 4 times 7, which is 12 times 7, which is 84. Okay? Not too terribly bad, right? So I can put that in my calculator. Calculator. I am going to show you, however, if you do put this in your calculator, because it already has a parenthesis in there, I'm going to do 9 factorial divided by 2 parentheses. So I have the inner one, 9 minus 6 factorial times 6 factorial, or I could put it in there originally, or I would put this one, 9 factorial and then 3 factorial times 6 factorial, because I'm pretty sure you can do the subtraction in your head, 9 minus 6, and then put this one in the calculator. Both of them would give you the same answer. Okay, it should give you 84. And you can try it and see which one you get, but you should get both of them, both ways. You should get the same answer. Oh, yeah. Yep, got both parentheses closed. Okay, so I'm putting 7 choose 5 combination into my calculator, and I'm going to get 21. Okay? Awesome. And then I'm going to do it again, and I'm going to put 11, choose 11. I have 11 things. I want to choose 11 of them. How many different ways can I do that? Well, this one should make sense. There's only one different way that I can choose 11 items if I only have 11 items. Okay? Good job, you guys. Okay, so now we're going to keep going on. Now we have a couple story problems to look at, kind of like we did before. Okay, so it says, parents have 10 books that they can read to their children this week. 5 of the books are nonfiction and 5 are fiction. So part A says, if the order in which they read the books is not important, so doesn't matter, how many different sets of 4 books can they choose? So doesn't matter how many sets of books can they choose. So I'm doing order doesn't matter, so it's a combination. And I know altogether I have 10 books and I want to choose 4. So I'm going to put that into my calculator, and I'm going to get 210 different combos. Okay, so I'm going to do it just so you can see it one more time mathematically. For those of you who don't have calculators or can't get into Desmos on your computer, remember it's Desmos, DESMOS, and then you would go to the stats, or just Google it, but it's under the stats button under functions. So it would be 10 factorial over 10 minus 4 factorial times 4 factorial, okay? Which gives me 10 factorial over 6 factorial times 4 factorial, which is 10 times 9 times 8 times 7 times 6 factorial. And then I have my 6 factorial, and I have 4 factorial, so it's 4 times 3 times 2 times 1. Okay, so the 6's go away. 6 factorials go away. 4 goes into 10 5 times. 3 goes into 9 3 times. And 2 goes into 8 4 times. So I get 5 times 3 times 4 times 7. And 15 times 28 is 210. Another way you can think about it is 21 times 20, which is 210. So a couple different ways to look at that one, different combinations. Okay, next one. In how many different groups of books are all the books either fiction or nonfiction? Okay, so they can either be fiction or they can be nonfiction. Okay, so I'm going to start with this way. I'm going to say nonfiction. We're going to do nonfiction here. Well, how many of my books are nonfiction? Well, 5 of them. And I get to choose 4 of them. And how many of my books are fiction? Again, 5 of them, and I get to choose 4 of them. So I'm going to put that in my calculator. Okay, how many different combinations do I get? Well, it's 5. And this one is also 5 because it's the same thing. And because it's an or, I get this one or this one. So I'm going to add them together. That gives me 10 ways. Okay, 10 different ways. Okay, good job. Whew. Okay, here we go to the next question. This one's just a little harder, just a little bit. Says a student senate consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. Part A says how many different committees of exactly 2 seniors and 2 juniors can be chosen. So I do want to just point out really quick the difference between these 2 questions. This one says or, and this one says and. So 2 totally different things. Or I'm adding and I'm multiplying. Okay? Just a little FYI there, or FYE, whichever one it is. Here we go. So we're going to deal with the seniors first. So how many seniors do I have? I know it doesn't matter because order doesn't matter because they haven't said I'm choosing a vice principal, principal, president, vice president, secretary. It doesn't say like a specific office that we're doing. We're just choosing 2 seniors from this many, from the seniors that are in Senate. So that means that order does not matter. So it's a combination. Okay. And I have 6 seniors and I want 2 of those seniors. Okay. And then I want 2 juniors. Well, I have 5 juniors and I also want 2 of them. And because it's an and, I want to multiply it together. I have this and this. Okay, so I'm going to put it in my calculator. 6 choose 2. 6 choose 2 is 15. And 5 choose 2 is 10. And so that is 150 different committees. Or different ways to make a committee, okay? All right, so now we're going to come down to this last one here, and we're going to read it. How many different committees of at most 4 students can be combined? So I'm going to pause for here a moment and see, pay attention to these words here, of at most. Well, that means there can be 4, a committee of 4, there can be a committee of 3, there can be a committee of 2, and I guess technically there can be a committee of 1. Okay, so I need to know how many. It doesn't say what grade they're in. Doesn't matter if they're freshman, sophomore, junior, or senior. Doesn't matter. They just want to have at least 4, at most 4, or at most 3, or 2, or 1. Okay, so I have to find a whole bunch of stuff here. And I also need to know how many people are in the Senate altogether. Well, 6 plus 5 is 11, plus 4 is 15, plus 3 is 18. So there's 18 students altogether. So I'm going to have 18. So if I'm going to do, if the committee for 4, I'm going to do 18 choose 4. And I'm going to put that into my calculator, and that gives me 3,040 different committees I can choose for the 4. And since it's at most, that means it could be less than 4. So I'm going to see how many I could have if I have a 3-person committee. So if I have a 3-person committee, 18 choose 3 is 816. Okay. And if I have a 2-person committee, it's 18 choose 2, I can make 153 different committees. Oh, I'm getting less and less. And God forbid you have 1 person on a committee. Whew, that's a lot of work depending on the committee. 18, choose one. Well, if I have 18 people, how many different ways is there to just choose one person? Well, that would be 18. And then I'm going to add all of those numbers together. And that will give me the total number of different committees I can make. Well, the total number of different committees I can make is 4,047 different committees. And I forgot an N, committees. Okay, so I want to just say we did most of this work on the calculator, which is fine. Just like I said last video and this video, Google it. Whatever calculator you have, the directions will tell you how to find permutations or combinations. And if your calculator doesn't do it, look up Desmos and it will do it for you. So you guys have a great day. If you need any help, message me. Just a quick note again, if you message me probably after 7 at night, I'm not going to get back to you till the next day. So just FYI on that one. So I will talk to you guys later. Have a great week. Bye, guys.